Hello, Algebra 2. Chapter 1.5 is an important section of the textbook, but because it covers a topic that we'll come back to again and again, and in fact you'll come back to frequently throughout your math career, and that is figuring out how to attack word problems. This chapter offers a number of different strategies. I don't want to suggest that any of the strategies in the textbook or any of these that I'm going to come to in a second down here that are my own should come before any others. This is really a toolkit that you're being provided with. Sometimes the hammer is the best tool to use, sometimes it's the screwdriver, sometimes the saw, and so forth. So we're going to go over most of these in this video, and I strongly recommend that you read the textbook section, chapter 1.5, carefully, maybe even twice, to make sure you have it and come into class with questions if you don't. As I mentioned here, the textbook, in the order that it presents them, offers 5 different tools or techniques: verbal, models, drawing diagrams, looking for a pattern, and guess, check, and revise. I would suggest, even before you get there, that you remember what we learned from unit analysis. Make sure you've identified what it is you're supposed to find. If you can, and if it helps, in some of these examples I'm going to show you it certainly will, identify what the units are going to be for that answer. Then start thinking about the information that's in the paragraph that will help you get the answer in the right units. We've been talking about this 3-step process every time that we've looked at word problems so far in the year, and now we're going to add these additional tools to our toolkit. So let's look at the first example they provide, and I say right here, read example 1 on page 33 first. I would in fact suggest that you make sure you've read each of these examples before you go too deep into this video, because they're going to make a lot more sense. I'm just not going to have enough time to read the paragraph to you. If these are the ideas that I gave you here, what are you supposed to find, what should the units be, and so on, and these are the tools that they're going to provide, verbal models, drawing diagrams, and so on. Example 1 starts off with this story here about the bullet train. Again, whether you hit the pause button here and read example 1 only, or hit the pause button and read them all, make sure you've read them all, because I don't have time to go over each of them in detail. What I want to make as a point, though, is that in example 1, the textbook suggests a verbal model as a solution to the problem. And it sets it up saying distance equals rate times time, which is great if you know this formula, that distance equals rate times time. But maybe you don't. And even if you do know the formula this time, I would suggest that there are going to be some cases where it's not going to be terribly obvious what the formula is for the solution. So then that brings me back to what I'd suggested over here. What is it that you're supposed to find? Well, if you look at it in detail, what are you supposed to find? You're supposed to find the speed. It's asked right here. What's the average speed of the bullet train? So as I put it up here, speed equals. So next step, what should the units be? Well, what are typically units for speed? Miles per hour is something that comes to mind with a car, but here we're measuring in kilometers, but it is kilometers and hours. Let's make the units kilometers per hour. Okay, so we've got that now. Okay, so what other info is there in the paragraph that can help? Well, we've got 550 kilometers and 2 hours and 15 minutes. Those are distance and time, just like here. Let's put them up there. And in fact, you'll find that this problem can be solved if you simply do this, apply these two values and this operation. 550 divided by, well, remember that 2 hours and 15 minutes is 2.25 hours. And if you divide that out, you'll get the same answer that the textbook does. Again, I'm not saying that theirs is the wrong approach, distance equals rate times time, but even if you realize that this is the formula, what you're being asked to look for is the rate. It's not the distance, so you have to rearrange this formula. Now, I don't want to suggest that the verbal model is a bad approach to take. Quite the contrary. In fact, I used it with you just a few days ago. When we were talking about the benefit concert, I set up essentially a verbal model at the beginning. I said, the way you're going to make your goal of $25,000 is by earning money from adults plus money from kids. And that right there, that's a verbal model. and then I simply plugged numbers into that verbal model, as you probably remember. I don't want to go into too much detail here, but we figured price per adult times adult tickets turned out to be $20,200, and what we were trying to solve for was price per child by times number of children. Now, the textbook's next example, example 3, I actually think is a fairly complicated story. I'm not going to read the whole paragraph here, but the point that I want to get at is they suggest that sometimes you're working with out-of-town clients, and sometimes you're working with clients presumably in Winchester. The textbook sets up a verbal model here. Total miles, in other words, the total miles that you drive to get to all of your clients, is equal to the miles per gallon that you get on the highway. They've told you that's 21, so the textbook goes ahead and puts in 21, times how much gasoline you spend going on the highway. They've decided to call that X, plus the local activities that you do. What kind of mileage do you get locally? Well, it says in town you only get 13 miles to a gallon, so they've put that there, and the amount of gasoline you use. Well, this is an interesting concept right here that I want to make sure you understand. They've said the total amount of gas you used is 40 gallons, and that's all you know. So if you use X on the highway, then whatever is left over after you use X from the original 40 is how much you use on the local miles. So that makes it 40, the original amount of gas you had, minus the X that you used on the highway. If you see this formula, then they go ahead and set it up like this and solve it out, and you can read for yourself and see that they come to the conclusion that X equals 10, which means, let's go back, that means that you used 10 gallons of gas on the highway. Well, I want to point something out. Let's say you decided, because you could have, why did X go here? Why didn't X go with the 13? Well, let's say it had. In this case, you would have had 600. Let's cover this up and try to do it step by step. Maybe it'll make a bit more sense if I do it this way. 600 equals 13x now, instead of 21x, plus 21 times the 40 minus x, instead of 13. All I've done is I've swapped the 13 and the 21, because you might have done that. If you did that, you would have solved it out like so, by first distributing the 21, and then combining the like terms. So you'd have had the two terms with x on the right and the two terms without x on the left, and you would have ended up saying negative 8x equals negative 240. In this case, you would have concluded that x equals 30, and you would have said, wait a minute, I got 30, you got 10, I don't get it. But remember, this is the 30 gallons that were used in town in Winchester, and these are the 10 gallons that were used on the highway. So they do still add up to 40, and it still does make sense. Next problem might make a little bit more sense. In this case, they suggest, they suggest that you draw a diagram to solve the problem. Well, I want to go back and point out one thing, and this is something that you easily can lose. There is an important detail in the fine print in the textbook right next to the picture, so make sure you notice that when you read this, because it's going to come back in a second. But let's say you've drawn a diagram just like the textbook did. The textbook's point is, from Sacramento to Omaha is a total of 1,776 miles. Great. They also point out some of the work was done by Central Pacific and some by Union Pacific. And as they've drawn in their diagram, Union Pacific actually did more. You get that sense from the fact that Union Pacific averaged way more miles per month than Central Pacific did. Okay, so let me give myself a little bit of space to start writing here. The point is that Central's work plus Union's work together is going to add up to 1,776 miles. Now, what is that work? Well, the only information that we have to plug in is the 10.3 miles of track per month. That's Central's work, and the 23.6 for Union. So I write those down. Now, here comes the point where the fine print that I'd mentioned before becomes important. It turns out, if you read the fine print, that Central worked for M months, and Union worked for less, 21 months less specifically. So they essentially work for m minus 21 months. If you did notice that, then what you would do is multiply 10.3 times m and 23.6 times m minus 21. So cleaning that up just like there. That's what I just said. Now let's distribute that 23.6, and what you've got is 10.3m and another 23.6m minus this piece. You're going to move that over. You're going to combine those two. Those two are going to become 30.9m. And if you do all the work out, you're going to find that m turns out to be about 67 months. Last example that I have time for in this video. In this case, now we've talked about verbal models, we've talked about the value of drawing a diagram, we're about to talk about the value of looking for a pattern. The story is that the lobby of this building is 20 feet high, and then here are the measurements to the top of the story for every story after the lobby. So they're calling the floor above the lobby the first story, and some buildings do that, especially in Europe. Well, there's not a whole lot that you can get out of this until you notice a pattern here, and maybe you have. How far did it take me to go up to the first story, and then to the second story, and then to the third? Each time it took me another 12 feet. If I realize that, if I realize there's always a 12-foot distance between each story, what it means is that every one of the floors except the lobby is 12 feet tall, then I got a pattern here. The height of the building is going to be that starting amount, that 20 plus 12 feet for every story. I've been asked about the 15th story. So I plug in 15 for S, and I get 20 plus 12 times 15, and I find that the height of the building is 200 feet. The textbook goes on and gives an example of guess, check, and revise. That's example 6. As you can see, I'm not going to have time to go over that. What I wanted to do in this video is just introduce you, like I'd said before, to the concept that you're going to need a toolkit of different techniques for attacking word problems. The textbook suggests these 4. I recommend that before you even get too far into using any of these 4, you've certainly identified for yourself, okay, so what am I looking for? What are the units of the thing I'm looking for? And what numbers and other information are in the paragraph that are going to help me? Your homework, you could, if you want to, try to pause and print. I think it's going to be easier if you simply print the file that I've put on my website. It's 2 pages. There are 3 problems on this first page and another 4 problems here. Notice that it goes, whoops, sorry about that. It goes 1, 2, 3, and page 2 starts with number 8. Don't worry about that gap. There really only are 7 word problems that I want you to work on. And I'll see you tomorrow.